All right, good morning, everybody. I'm just going to go over a few things with you that have to do with conditional probability. You'll notice here there's actually a definition of conditional probability, and that's when the outcome depends or occurs, or the occurrence of the first event or outcome of the second event in a way that the probability is changed. We use the example in class that if I take a marble out of a bag and then I don't replace the marble, then it's going to affect my probability. And we're going to do an example like that. An example would be having higher grades and getting a scholarship are dependent on one another. Conditional probability of an event B in relationship to event A is the probability that event B occurs after event A. Now there's a couple different ways that we note this. It's usually noted with this symbol right here. There's a line between the B and A, and it's actually written the probability of B given the probability of A. Very important to note that it does not mean that you're dividing the probabilities of B and A. It's actually a better example is down here. If you'll jump down to the bottom here, this is the actual formula, and this is the one that I'll be using. So in the numerator, it's the probability of A and B, and we use an intersection symbol, and we'll be talking about that later in the week, divided by the probability of A. So it's the probability of both things happening divided by the probability of A. All right, so we're going to go through this first example here. And on the first example, it tells us that we are, Alright, so in this first example, it's saying that in a shipment of 25 microwaves, 2 are defective. So we know that 2 out of 25 microwaves are defective. Okay, so that's the first piece of information they're giving us. It says if 2 ovens are randomly selected and tested, find the probability that both are defective. If the first one is not replaced after. So this is a conditional probability. Since we're not replacing it, the probability of the second event is affected by the first event. So we're looking for the probability that the first one is defective and the second one is defective. And it says that we already know that we want them to both be defective. So that means the first one would have to be defective. So if you look up at the top here at your equations, right here, you'll notice that you're given this formula right here, which says when 2 events A and B are dependent, the probability of them both occurring, the probability of A and B, and this is only for dependent events, so that's very important, only for dependent, is the probability of A times the probability of B given A. So that's that conditional probability. So what we're going to do is we're going to use that formula. So we're going to say what is the probability that the first one's defective times the probability that the second one's defective, given that the first one is defective. All right, so the probability that the first one would be defective is 2 out of 25. We know that because there are 2 defective microwaves out of 25. Times, now we've already taken one of the microwaves out. So instead of having 24 microwaves to choose from, or 25 microwaves to choose from, we only have 24. So that would be 24, and there's only one defective microwave left. So my answer here is going to be 2 out of 600. All right, on this next example here, we are told that the WW Insurance Company found that 53% of the residents of a city had homeowners insurance. So the probability that you'll have homeowners insurance is equal to 0.53. We want to convert that to a decimal. Of these clients, 27% also had automobile insurance. So this means the probability that they have both is equal to 0.27. It also means that if they have homeowners insurance, another way to write this is the probability that you have auto insurance if you have homeowners insurance is 0.27, since they have both. So it said if a resident is selected at random, find the probability that the resident has both homeowners and auto insurance. So the probability that they have homeowners and auto insurance is equal to the probability that you have homeowners insurance times the probability that you have auto insurance given that you have homeowners insurance. So we know this is 0.53 times and then 0.27. Now, since it's given as a decimal, then your answer will also be a decimal. So your answer is 0.1431. Or you could write that as 14.31%. All right, this next one is a little bit more complicated, so I'm going to kind of draw a tree diagram out. I think this is one of the ways that you can visually see what happens. I'm also going to take out some information here. We have two boxes. We have box 1, which we're going to represent as B1. And in box 1, it has 2 red marbles, and then it has 1 blue marble. So in box 1, there are a total of 3 marbles. In box 2, which we're going to represent by B2, there are actually 3 blue marbles and 1 red marble. So in this particular box, there's a total of 4. So the first probability that we do, it says if it falls heads up, box 1 is selected, and so you flip a coin. If it's heads up, box 1 is selected, and a ball is withdrawn. If it falls tails up, box 2 is selected, and a ball is drawn. So what's going to happen here is you are going to find the probability that you pick a red ball. Now this is a dependent event because where you get the red ball from is dependent on which box you initially get. So to start off, the first thing you do is flip a coin, and when there are actually 2 options, and that is that you'll get box 1 or you'll get box 2. Now the probability of getting box 1 is equal to 1/2, and the probability of getting box 2 is also equal to 1/2, since there's a 50-50 chance that you'll get each one. Now, after I determine which box I get, when I go into box 1, there are 2 possibilities. That is that I'll either get a red marble or a blue marble. So the probability of getting the red marble and then the probability of getting a blue marble. Now, getting a red marble is dependent, of course, that I'm in box 1. So this is one of those, the probability of getting a red marble given that I'm in box 1. And then down here, this would be the probability of getting a blue marble given I'm in box 1. Now the reason this is important is remember that in box 1 there are only 3 marbles. So the probability of getting a red marble given you're in box 1, that's a probability of 2/3. The probability of getting a blue marble when you're in box 1 is equal to 1/3, again because you have just 3 marbles in the box. This is different if you are in box 2. In box 2, you also have the probability of getting a red marble or a blue marble, But here the probability of getting a red marble given you're in box 2 changes because in box 2 there are 4 marbles to choose from and only one red one. So you have 1/4. Here the probability of getting a blue marble given you're in box 2 has also changed because in box 2 there are 4 marbles to choose from, but 3 of them are blue. So this would be 3/4. One thing you should always check when you do a probability tree is each level of branches should add up to 1. So we've got 1 here for our first. Our second one, 2/3, 1/3, that should add up to 1. Here we have 1/4 and 3/4, that should also add up to 1. So now that we have all of our probabilities, what we want to do is find the probability of getting a red marble. So there's 2 possibilities. You could get there's the probability of going into box 1 and getting a red marble, or, there's that word or, the probability of going into box 2 and getting a red marble. Now, these are dependent events because getting this red marble is dependent on which box I'm in. So for the first one, that's the probability of getting box 1 times the probability of getting a red marble given that you're in box 1. The word or here indicates that you want to add those probabilities together. And so here we have the probability of being in box 2 and getting the red marble. So that's the probability of box 2 times the probability of getting a red marble given that you're in box 2. Now to get the values of all these probabilities, what we want to do is refer back to the tree. Remember those key terms, and means to multiply or means to add. So here we have 1/2 times 2/3 plus 1/2 times 1/4. So that's going to give me 2/6, which is also 1/3, plus 1/8. Get a common denominator. This will give you 11/24 as your probability. Okay, in this problem, I'm going to ask you to read it to yourself real quickly, but you'll notice you end up with the probability of NP, so not parking, and getting a ticket, is 0.06, and the probability of being in a no park zone is equal to 0.2. So the question being asked here is, what is the probability you get a ticket given that you're in a no park zone? So this is just set up slightly different. Remember that the formula for this is the fact that this would be equal to the probability of both of these things happening. This comes from the formula at the top, divided by the probability of the given. So that's equal to 0.06 divided by 0.2, which in this case is equal to 0.3. All right, I'm going to go over this last example with you. The key to this problem is using this table effectively. If you read the problem, the question is asking you, what is the probability of saying yes given that you are a female? So this is the probability that you said yes and you are a female, divided by the probability that you are a female. So if you look over here at the table, there are 8 females who said yes. So that's 8 out of 100 divided by, and then the probability of being a female, there are 50 females out of 100. So you simply then want to simplify this fraction, and that is going to give you 8 out of 50. All right, and our last example, real quickly, is the probability of being a male given that you said no. So that's the probability of being a man and you said no, divided by the probability that you said no. So being a man and said no is 18 out of 50, divided by the probability that you said no, which is 60 out of 50. So your answer would be 18 out of 60.